Hello and welcome back to the shop. I haven't been doing much this last week. I haven't been in here at all this last week. I've not been feeling too well, so I haven't been able to come in. And it's quite cool in here now. I've got a problem with the diesel heater on the wall there. The thing stopped working. Originally when I went to start it up about 2 weeks ago, the battery was knackered. So I get another battery. Oh, by the way, it's the wrong type of battery anyway. I need to get a proper leisure battery for the heater. But anyway, I'll sort that out. But I've got a new battery now, and it started the diesel heater. The diesel heater was running, and after a while it just stopped, it conked out. And I did some checking and investigating and couldn't find out what the problem was, so I started ordering a few bits for it. I got a new pump, and I got an overhaul kit for it, a new glow plug and glow plug spanner and all this kind of thing. And I started doing some work on it last week. I came in and actually did probably about 3 or 4 hours on it. Got it back together again. It still wouldn't work. It would start up, it would run for a short period of time, and then it would trip out. And I thought, I've got a problem with electrics, and you can't get your probe meter into the connections. So I thought, right, okay, so I rewired it, and it didn't make any difference whatsoever. So I think it's probably a problem with the motherboard or the controller on the wall just behind me. But anyway, I need to get that sorted out because winter's coming, and coming in here, I don't want to be freezing to death. So I need to sort that out. But anyway, that to one side, that's a separate problem altogether. Right, we have here some hot rolled bar. This is 40 by 10 mild steel bar. Now this is the stuff that we talked about in the last video for these series of stretchers, which will fit between the chassis, which is the tenders on the bench over there. That's what I'm pointing to. So we've got to machine this down to 1 inch and 3/32, and it's 40mm at the moment, so we've got quite a bit to come off that. And we're going to do it on the planer, because I know you all like watching the planer machine working. It's a nice machine. But a couple of things we've got to do first. The first thing is we're going to put some tension on this belt here. This belt's as slack as, well, it's best not to say really, but it's slacker as anything. It's actually hanging off down below the pulley at the bottom. Now what we've got here is a system where the 2 centers are fixed, and we can't change that at all. It's fixed. So the only way we can tension the belt is by taking some out and reconnecting it together. If this was a stitched belt or a glued belt, we'd be knackered, because you'd have to keep doing that every time you wanted to shorten it. So what people do is they put an ordinary fastener in, an alligator type fastener. Yeah, like that one there. You can't see it very well from there. So what we're going to do is we're going to take some out. Yeah. I'm going to put a new fastener in, and I've just about got enough of the fasteners left to do one more cut on this here. I've ordered some new stuff, by the way. I've ordered some new set of belts for spares, and I've ordered 12 sets of clips. So they'll be here in probably a couple of weeks. But anyway, this one's not brilliant, but it's not as bad as that one. This one's the dried one. It is actually, you can probably see it slipping there. You can hear it probably. But anyway, we're going to have a look at the belt drive on it. So we'll first have a look at some of the technology behind the flat belt, and I'll just explain to you what I'm going to do and why I'm going to do it. Alright, I've come around the other side of the planer now, and you'll see there's a big book here on the planer table. And this is my Bible from when I was an apprentice. It's all my technology notes and stuff in here when I was an apprentice fitter. There's a very famous company not far from where I live now. Well, I say not far, probably about 18 miles. But anyway, we covered all kinds of things when we were an apprentice, as I'm sure many of you did. One of the sections in my book here is belt drives. We did all kinds of things. There was shaft alignment, bearings, gears, chain drives, clutches, brakes, nuts and bolts, kinetic lifting, lifting equipment, all kinds of things. Anything that the plant engineer would encounter in their activities as an engineer. So, but anyway, flat belts, they're an important aspect of power transmission. Not so common nowadays as they were obviously in the old days. But when people say we're going to put some tension on the belts here, how much tension? How do you know how to tension the belt correctly? Well, on flat belts, what we have is we rely on the percentage stretch of the belt. So, let me just read to you here. Flat belts, gives you a little bit of background about them. The power transmission capacity of flat belts depends largely on the degree of initial tension. The amount of tension is related to the amount the belt is stretched on installation. Prior to installation, two marks a certain distance apart, say 100 millimeters, and for people who work in an imperial system, because an inch can be divided into 1,000, it can be divided into 10, so you could put 10 inches and then just measure the increments in tenths of an inch. So prior to installation, two marks a certain distance apart, say 100 millimeters, are marked on the belt. When the belt is installed and the pulleys moved apart, okay, we can't move our pulleys apart, that's a big problem, because the problem is there is how do you know how much to take out to get the right tension? And you don't. If you had a whole series of these machines, exact same distance apart, every one of them, you would probably have written down somewhere exactly the length of belt that you were required to give you the exact stretch that you wanted. And it's probably written on the wall or something like that. So you didn't have to think about it. You come out, oh yeah, that's it, that's it, that's it. So you knew how much to take out, and even then you might have to take a little bit out because the belts might stretch a little bit different from each other. But anyway, it says here, when the belt is installed and the pulleys moved apart, the two lines will move further apart. So when you put the belts on, okay, we could, if we couldn't move them, we would move that and we'd get this thing would stretch, the belt would stretch. But we haven't got that option, so what we would have to do is to roll the belt on. Yeah. It says here, the following amounts of stretch expressed as a percentage are recommended. Okay, they're a guide really, they are a guide. Lightly loaded drives, 1 to 2%. Normally loaded drives, 2 to 3%. And heavily loaded drives, 3 to 4%. Okay, now it does say about jockey pulleys or spring-loaded tensioning devices can be used as an alternative to moving the pulleys apart, which should always be applied on the outside of the belt to increase the arc of contact, in other words, the angle of wrap. You want the biggest angle as possible of the belt in contact with each pulley to make sure that you drive. You don't want that sticking out here because you're reducing the angle of wrap. Yeah. So there you go. Now this drive on this machine here, I believe it's going to be, well, in my opinion, it's a light loaded drive, it's not a heavy loaded drive. So we'd be going for like 1 to 2%. And I don't want to overload things anyway. You might find that, it should be a 3 to 4 or something of that nature, but the problem is this belt's got to move from pulley to pulley. And if it's too tight, would it still move? I don't think it would. So we've just got to put enough tension on there to make sure that we transfer the drive and it doesn't slip. Flat belts will always slip, all belt drives slip except a timing belt. This timing belt doesn't slip. But flat belts will slip. And in that sense it does give you a bit of flexibility, so it's considered a flexible drive. But anyway, we're going to look at this, we're going to pull the pin out at the belt. We're going to look at taking a bit more out of it, so we're going to try and gauge how much we've got to take out. So I don't want to put too much on. I don't want to pull this down and try and lift the planer up. I wouldn't be very good at all. I'll let him put the book out the way and we'll get on with doing that. It's amazing, isn't it? This Bible, I used it all the way through my career. A lot of people I served my apprenticeship with, that were going straight in the bin as soon as they came at the time. And I wonder where they are now. It's a pretty poor reflection on what they thought about what they were doing. But anyway, that's another point. Right, let's have a look at this belt. Alright, you can see the belt here. Can you look how slack that is there? In fact, you might be able to see if I pull down, you might be able to see how much it's loose. It's not very good at all. Look at that. See? That's no good, is it? Right, where's the fastener? Here it is. Right, you can see this is the fastener here, look. It's one of these alligator type ones. Where you can see, I'm just pulling these apart together. Can you see how much slack there is there? You be careful, I don't want to bend things, but I've got a bit to take out. Just make sure that's right. This is the return stroke side, so we don't need to worry too much about getting it brilliant, but we want it good. We don't want to waste power going forward, and we don't want to overload it either. So we're going to cut a fair bit out of that. What I would normally do is cut it out just to the top of the clip, the alligator clip here, and then I'd redo it. But I think I need to go just a little bit further than that on this time. Right. The little pin itself is like a spring steel type material, and it's got a plastic sort of a coating on it. So it's a low friction sort of a pin. I mean, you could use a welding rod if you would wanted to, if you were desperate. But the problem with that is welding rod is mild steel, so it doesn't have much strength. There you go. It comes apart there, you see, that's the pin. You have to cut down to length. It's really similar to a conveyor belt as well, there's not much difference at all. 1, 2, 3, 4, 5, 6, and there's 6 teeth. So what we're going to do is we'll take that off. Take the belt off, take it to the bench and cut a piece off. And then put a new clip on. Right, I've marked a line on there. You might be able to just see it. I'm going to move to that. That little square is in the centre of the screen. Hopefully you can see that. That's about 5/8 of an inch we're going to take off there. It'll cut easy enough with a pair of scissors, this stuff will. It's not like a thick leather belt. Not very square either. It's important that it's square. You mustn't have it at an angle, otherwise your belt won't track properly. So there you go, I've just cut it off. Yeah, be square enough, that will. For what it is. We've just got enough clip material left. Just a alligator type. I don't know if you can see that. I'm going to put my hand there. Maybe you can see. I don't know how this thing focuses or not. I'm sure if you did a little search on the internet you'd see these things. These are small obviously for this thin belt. Get some big heavy belts, some big conveyors. They got some big heavy fasteners. You have to have the machine for wind them on to close the alligator things down. Right. So we're going to put that on there. To get the teeth to mesh properly, I've got 7 on this one, this end, and I've got 6 on this one. So there's just enough material there for us. Problem is when it's that thin like this here, is getting the thing to start. So what I have, I use a piece of welding rod, and I'll put it there on the end, and then I'll put that on there. That'll set me distance for me. I'll close it down with pliers first. You get little machines which will put these on for you. You put them in the vise and you can fasten your clips. It'll give you perfect every time. But when you haven't got them, if you're in the field and you haven't got that with you, you've got to do something. And you've got to do a good job as well. So that's where your skill as an engineer comes in. I'm sure a lot of you have had to do that kind of thing yourself. Right, where's my pliers gone? Alright, I've just been get some dinner, so I've come back now obviously. It's a bit warmer in the house. I've got my fire on in the house, so I'm quite pleased with that. That's my most prized possession, that is my fire. But anyway. Right, what I'm going to do is I'm just going to start pinching this up just to close these down to get things started. Make sure we don't close it down further than we need to. So can you see it's starting to come now? It's starting to close down just with the pliers. And I put my rod in there, and what it stops you from closing the hinge down on the end. If you close the hinge down, you can have problems. So that's just there as a stop it from closing down. And there's a little piece of wire across there which joins them all together, and I'm lining that up with the end of the belt. If you got one of the machines, it'll set that distance for you here correctly when you put it in. And all we're going to do is put it on the iron block here, the steel block, and we'll give it a good smacking with the hammer. We won't go mad, it'll be nice steady taps. We don't want to damage anything. This will damage very easily. So what we will do is leave our pin in, because the pin will give it some structural support around the hinge, sorry. Tap, just there. It's broke off from there. No problem. Finicky little things sometimes, these kind of. And there we are, it's on now. See, we haven't lost the shape. Probably can't see with my hand there, we need a darker colour behind it, don't we? What we got? Use my old square box, can you see there now? We've still got a nice radius in the top of the hinge there. And this is how much we've cut out, so it's 5/8 we've cut out, nominal. We talked about tension earlier on. What we'll do is we'll mark on here. We'll get our rule. You see a standard rule, a 12-inch rule, even in in imperial. You've got fractional scales at the top here, and you've got decimal scales at the bottom. So if we mark a piece 10 inches on here, use our felt tip, we'll mark a piece 10 inches. Yeah. So 10 inches is there. There you go. So we've got a couple of lines 10 inches apart, and we can measure the percentage extension. Let's do it in metric as well for metric people. It's going to be a bit more difficult to see in the metric one because it's a smaller scale. At the end of the day with the drive, all you're trying to do is to transfer the drive positively without any unnecessary slippage. Sometimes slippage is necessary. Overload and things of this nature, you want something to give, and your belts will give. That's one of the reasons why they use them. Anyway, here's our belt ready to go back on now. We'll put it back on and we'll try it. Alright, I've got the belt here. I'm going to start feeding it through. And this belt has to twist. One twist in it. And it's because it's reversing on this spot. This is the reversing pulley. Alright, so we'll feed this through underneath the pulley. And one twist, that's all. So what will happen is it will twist like that. So it goes from the back of that one to the front of that one. And that one connects like that there. Yeah. Got to get yourself orientated right. I don't think it matters which way, whether you twist it that way or the other way, as long as it's got the twist in it. So if that's up there, let's just check what we're doing. I think I prefer that like that. I prefer it like that. The fastener in there. That'll be better. So that goes in there. Just push it together. Put that through. There we go, that's gone through. It's already a little bit bent on the end. So right, what we've got here then is we've got Alright, there's our clip, pin through. There are the lines, can you see them? Just about. That's the 10-inch one, and that is the 100mm one. So, let's have a look at this one here then. Can you see? Yes, you can. Now, let's have a look. That's about 10.1 inches. So we got about 1%, haven't we? And that's in the region where we said we wanted it. 1%, I think it was 1 to 2 in our book. We will check that in a minute, it's over there on the bench. But I'm happy with that. But when we do it for the metric, it's difficult to tell. Although we can see 101mm, thereabouts. So yeah, so you can do it either way. But that's giving us the tension that we need. You can see that's not too taut. I'm happy with that. Right, ready to give it a try? Okay, let's see what happens, eh? Slipping on that belt now. That's just that little noise there, it's just a clip running on against that side there. Not worried about that. Just watching the mechanism here, it's not going fully over. See, a little bit further to go, which makes it okay. It's alright that way. Watch it now. See, it's not all the way. Right, that's typical on this. I've just been showing you what the problem is. And the battery went flat on the camera, so I've had to just change it. But anyway, the mechanism here for driving the belts across, switching the belts to give us forward and reverse, the lever mechanism here is binding. There's no end float at all in that. We need some end float. I'm going to take this bell crank off here, so I'll pull the table out a little bit more, and I've got the workmate under the other end here to support just in case. We'll take this out, we'll have a look at it on the bench. Get my file to work. Right, let's see if we can get this in. There you go. Right. Just get in. You break your arm in 3 places to get into some of these things sometimes. I mean, it could be worse, it could be one of these modern engines on a vehicle my pickup truck in the driveway there. It's a brand new one, a Ford Ranger. And it's got a V6 engine. And you open the bonnet on it, it's just nothing but pipes and cables and, God man, I wouldn't like to have to do a job on that. And where's the, let's take that out, a little bit more, there you go. Right, you can see the bell crank here. Now, I know where that goes. See, these are free, as they should be. But it's this face here. When we tighten the grub screw up, it's pulling things together. We don't want that. See, that's free, like that. But what we haven't got is any end float. So we need to do something about that. And what we can do, we've got a spacer here. Yeah, this goes on the outside, so it fits, the spacer fits on there, and then this goes on there. But when we tighten in the grub screw up, because of the position of the dimple here, it's pulling the thing together and it's closing down our end float, getting rid of our end float. And what it's doing is it's clamping in place, and we don't want that. What we might do then is if we skim, or can we skim that off there? Is there enough to hold in the lathe there, do you think? Or do we just get a new piece of bar and part it off on the lathe, and I can show you how to part off on a small lathe? No problem whatsoever. Let's do that, eh? I'll clean this crap off my hands.